When sizing conductors from a junction box to manual starters, several steps are involved to ensure safety and compliance with electrical codes. This example addresses a scenario involving a 480-volt feeder originating from a 30-amp fusible disconnect in a motor control center, supplying power to two size 1 manual starters for air handlers. Each air handler has a full load amperage of approximately 8 amps. The objective is to determine the appropriate conductor size from the junction box and the load side of a field fuse disconnect to the manual starters. Firstly, you need to determine the ampacity of the feeder. The provided information states that the feeder is rated for 30 amps at 480 volts. This establishes the initial capacity of the circuit. Secondly, calculate the total load current. This is the sum of the full load amperage of the two air handlers. With each air handler drawing 8 amps, the total load current is 8 amps plus 8 amps, equaling 16 amps. Thirdly, consider applying an ampacity correction factor. Since the conductors are routed through a junction box and manual starter enclosures, heat buildup can be a concern. The ampacity correction factor accounts for this by directing the conductor's capacity. In this case, an ampacity correction factor of 0.8 is given. This value may vary depending on the specific conditions and applicable electrical codes, so always consult the relevant tables and guidelines. Fourthly, calculate the required ampacity. This is determined by dividing the total load current by the ampacity correction factor. In this scenario, 16 amps divided by 0.8 equals 20 amps. This means the conductors must be able to safely carry at least 20 amps. Fifthly, select the appropriate conductor size. Based on ampacity tables for 600-volt THHN conductors, a common type of wire used in electrical installations, the minimum conductor size for 20 amps is 12 American wire gauge, or AUG. It is crucial to consult the appropriate ampacity tables in the National Electrical Code, or NEC, or other applicable standards to ensure accurate conductor selection. These tables provide the allowable ampacities for various conductor types and sizes based on factors such as insulation temperature rating and installation conditions. Therefore, based on these calculations and considerations, the conductors from the junction box to the manual starters should be 12 AWG 600-volt THHN. It is always recommended to consult with a qualified electrician or electrical engineer to verify these calculations and ensure compliance with all applicable codes and regulations. Furthermore, proper installation practices should be followed, including using appropriate connectors and ensuring proper termination of the conductors. When dealing with electrical systems, safety should always be the top priority. Always to energize the circuit before working on any electrical components, and use appropriate personal protective equipment, such as insulated gloves and safety glasses. Before starting any electrical work, it is important to verify that the circuit is energized using a reliable voltage tester. This will help prevent accidental electrical shock. In addition to the conductor size, it is also important to consider the insulation type. In this case, THHN insulation is specified, which is a common type of insulation used in electrical wiring. THHN insulation is rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. It is important to choose the appropriate insulation type based on the environmental conditions in which the conductors will be installed. The length of the conductors should also be taken into consideration. Longer conductors will have a higher voltage drop, which can affect the performance of the equipment being powered. Voltage drop can be calculated using various formulas, and it is important to ensure that the voltage drop is within acceptable limits. The NEC provides guidelines for voltage drop in branch circuits and feeders. Proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or blow the fuse, thus preventing electrical shock. The grounding conductor should be sized according to the NEC. In addition to the above considerations, it is also important to follow all applicable local codes and regulations. Local codes may have additional requirements that must be met. It is always best to consult with a qualified electrician or electrical inspector to ensure that the installation is in compliance with all applicable codes. Proper labeling is also important for electrical safety. All electrical panels, disconnects, and junction boxes should be properly labeled to identify the circuits they serve. This will help prevent confusion and make it easier to troubleshoot problems in the future. When working with electrical systems, it is important to be aware of the potential hazards. Electrical shock, arc flash, and arc blast are all serious hazards that can cause injury or death. It is important to take all necessary precautions to protect yourself from these hazards. This includes wearing appropriate personal protective equipment, using insulated tools, and following safe work practices. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Attempting to perform electrical work without the proper training can be dangerous and may result in serious injury or death. Regular maintenance is also important for electrical systems. This includes inspecting the wiring, connections, and components for any signs of damage or wear. Any damaged component should be replaced immediately. Regular maintenance can help prevent electrical problems and ensure the safe and reliable operation of the electrical system. In addition to the technical aspects of conductor sizing, it is also important to consider the cost of the materials. Different conductor sizes and insulation types will have different costs. It is important to choose the most cost-effective solution that meets all of the technical requirements. When selecting electrical equipment, it is important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or all. UL listing indicates that the product has been tested and meets certain safety standards. Using UL listed products helps to ensure the safety and reliability of the electrical system. It is also important to choose electrical equipment that is properly rated for the intended application. This includes voltage, current, and horsepower ratings. Using equipment that is not properly rated can be dangerous and may result in equipment failure or fire. When installing electrical equipment, it is important to follow the manufacturer's instructions. Improper installation can void the warranty and may also be dangerous. If you are not comfortable installing electrical equipment yourself, it is best to hire a qualified electrician. In addition to the above considerations, it is also important to be aware of energy efficiency. Choosing energy-efficient electrical equipment can help to reduce energy consumption and save money on electricity bills. There are many different types of energy-efficient electrical equipment available, such as LED lighting, energy-efficient motors, and variable frequency drives. When designing an electrical system, it is important to consider the future needs of the building or facility. The electrical system should be designed to accommodate future growth and expansion. This may require installing larger conductors or adding additional panels and disconnect. It is also important to consider the impact of the electrical system on the environment. Choosing environmentally friendly electrical equipment can help to reduce the carbon footprint of the building or facility. There are many different types of environmentally friendly electrical equipment available, such as solar panels, wind turbines, and electric vehicle charging stations. Finally, it is important to remember that electrical safety is everyone's responsibility. By following safe work practices and taking the necessary precautions, we can all help to prevent electrical accidents and injuries. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and safety practices. It is important to stay up to date on the latest edition of the NEC to ensure that electrical installations are safe and compliant. In addition to the NEC, there are also other standards that may be applicable to electrical installations, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards provide guidance on specific aspects of electrical design, installation, and maintenance. When working with electrical systems, it is important to have a good understanding of electrical theory. This includes concepts such as voltage, current, resistance, and power. A good understanding of electrical theory will help you to troubleshoot problems and ensure that the electrical system is operating properly. There are many different resources available to help you learn about electrical theory, such as textbooks, online courses, and training programs. It is also important to have access to accurate and reliable test equipment. This includes voltmeters, ammeters, ohmmeters, and other specialized test equipment. Accurate test equipment is essential for troubleshooting problems and verifying the safety of electrical installations. Regular calibration of test equipment is also important to ensure accuracy. When troubleshooting electrical problems, it is important to follow a systematic approach. This includes gathering information, analyzing the symptoms, and testing the components. A systematic approach will help you to identify the root cause of the problem and resolve it quickly and efficiently. When repairing electrical equipment, it is important to use only approved replacement parts. Using non-approved replacement parts can be dangerous and may void the warranty. It is also important to follow the manufacturer's instructions when repairing electrical equipment. After completing any electrical work, it is important to thoroughly inspect the installation to ensure that it is safe and compliant. This includes checking the wiring, connections, and components for any signs of damage or wear. It is also important to test the operation of the equipment to ensure that it is functioning properly. Finally, it is important to document all electrical work that is performed. This includes recording the date, time, and nature of the work, as well as any materials that were used. Accurate documentation is essential for tracking maintenance and troubleshooting problems in the future.